How did electronic component reliability evolve historically? Imagine a world where electronic devices fail almost as soon as you start using them. That was the reality in the early days of electronics. Back then, components like vacuum tubes and early transistors often broke down quickly. These parts were made with primitive materials and simple manufacturing methods, which meant they were fragile and had short lifespans. For example, vacuum tubes could burn out after just a few hundred hours of use. As technology advanced, engineers looked for ways to make these parts last longer and work more reliably. In the mid-1900s, the invention of the transistor changed everything. Transistors were smaller, more durable, and used less power. But they still faced issues because manufacturing processes were not yet refined. The real breakthrough came in the late 1950s and early 1960s with the development of the planar process. This technique, created by Gene Hoerney, allowed for more consistent and stronger semiconductor devices. It protected the delicate surfaces of transistors and made mass production possible. Robert Noyce used this process to create the first integrated circuit, which combined many transistors into a single chip. This reduced the number of points where failures could happen, making the devices more reliable. During the 1960s and 1970s, reliability testing became more sophisticated. The aerospace and military sectors pushed for components that could withstand extreme conditions and last for many years. They developed standards and models to predict how long parts would last and how they might fail. This focus on quality helped improve the durability of electronic components used in space missions, aircraft, and military equipment. In the 1980s and 1990s, the rise of personal computers and consumer electronics sped up the need for reliable, low-cost parts. Companies in Asia started producing high-quality components at lower prices. This led to a shift where commercial off-the-shelf parts often outperformed specialized military parts in reliability. During this period, failure rate models moved from being based on complexity to understanding the actual defect mechanisms inside the components. As technology kept advancing, researchers began to look beyond just hardware. They studied how software and human interaction could cause failures. Today, we see innovations like self-healing circuits and systems that can swap out faulty parts without shutting down. These developments help keep devices running smoothly even when individual components fail. You can see these improvements in everyday electronics like smartphones, medical devices, and aerospace systems. Miniaturization and integration into single chips have reduced the chances of failure. Accelerated testing and environmental stress screening now help predict how long a component will last and catch problems before they reach consumers. Over time, electronic component reliability has evolved from fragile, failure-prone parts into highly dependable building blocks of modern technology. This ongoing progress helps us understand failure causes better and design more resilient products for the future.